Hi friends, welcome to follow up. Let's have a look at problem 2824. Count pairs whose sum is less than target. In this video, we are going to explain a solution based on sort and the two pointers trick. So here we are given a zero-indexed integer array called nums of length n, and also we are given a target. So we want to find the number of different pairs ij. Such that nums I plus nums j is less than target. So here we notice that we need the indices to be different, right? So in the two examples given, so the outputs are 3 and 10 respectively. So you can look at the explanation to digest the output. So here the constraint is the following. First, the length of this list is bounded above by 50. And nums I, in other words, the elements and the target is in between -50 and +50. So with that said, we are ready to look at the analysis. So here, because we want to find the different pairs of indices such that the condition holds. So here we just need the two indices to be different, right? So as long as they are different, they will have an order relation. So then, as long as their sum is less than the target, we count it as one pair. In other words, so the specific order is not that essential, so we can do sort. So here, after we do sort, so we can observe one order relation. So here, sort we mean sorting from small to large, right? In other words, increasingly. So after sorting the nums list, so we can assume I be one left index, and the R be the corresponding largest right index, such that the sum of nums I plus nums R is less than target, because we sort the list in an increasing order. So if we increase R further, it will violate this condition, right? And then we know that we can count all the pairs like I, starting from I and ending at any position between I and R, right? But we couldn't include the I. So if we have two indices, I1 is less than I2, then the corresponding indices for R2 will be less than or equal to R1. So this order relation enables us to use two-pointer trick effectively. So here, when we scan each position I from left to right, the corresponding R pointer shall decrease. So in other words, we don't need to start over from the tail of the list. So if we can grasp this relation, then writing the code using two pointers is very straightforward. So now we are in a position to look at the coding part. So first, I'm going to initialize a result variable. So we are going to, this is a counting variable, we are going to return its final state. And then one important step is we can do a sort. So if we write like this, it will automatically sorting the nums list from small to large, in other words, increasingly. So now we can run the two-pointer trick. So first, let's introduce another variable, n. This is the length. Well, this is just for convenience. Then at the very beginning, the right index will be at n-1, right? And then for each index, for left in range, so we are going to start from n-1, right? Ending at n-2, in other words, the second to last elements. The reason is that we want to find different pairs, different indices. Then let's write a while loop. So while right is larger than left, and nums right plus nums left is greater than or equal to target. So we are going to decrease the right pointer, increment by 1, decrement by 1. So after we exit this while loop, then there are two possibilities. First, right will be less than or equal to left. So in this situation, so for the current left, there's no right index such that the sum is less than target, right? And then we can just stop, because if we increase the left, then the number becomes even larger. So afterwards, it's impossible to find pairs with sum less than target, right? So this is one case if right is less than or equal to left. So we just need to break, right? So otherwise, so we are going to have this condition, right? So nums right plus nums left is less than target, and then we can count all the pairs. Count the pairs. So the pairs, so the left is starting from left. Then we can the right index will be start from left plus 1, ending at the right, right? So if you count the counting from left plus 1 up to right, so the total number of indices will be right minus left, right? So we're going to do result increment right minus left, right? So here in this condition, even in this case, we can do like this. We do not need right else, because if right is equal to left, so we're going to increment by 0, right? So with that said, we are ready to return the result, right? So this actually forms one complete solution format. So before we make any comments, let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So with that said, that's about it for this video. Thank you.